Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam LTAM. This is from the last exam LTAM from fall 2019. A couple, Frankie 55 and Johnny 65, that's 55 and 65 are the ages of those two, purchase a single premium annuity that pays $10,000 per year continuously while they're both alive, and pays $8,000 per year continuously while exactly one is alive. You are given that Frankie and Johnny have independent future lifetimes. Delta, the force of interest is 5%. A bar 65, that's cost of continuous life annuity on a 65-year-old, and Johnny is 65, is 12.8916, and A bar 75, well, no, none of them is 75, although Johnny will be in 10 years, and at that time Frankie will be 65, so this really refers to a situation 10 years from now. So the cost of life annuity paid, unit life annuity paid to a 75-year-old continuously, actuarial present value is equal to 9.7262. The force of mortality at age 65 is 0.05605. Force of mortality at age 75 is 0.017552. We also given that TV0, upper 0, represents the reserve at time t, given that both Frankie and Johnny are alive at time t. TV upper 1 represents the reserve at time t, given that Frankie is alive at time t and that Johnny has died before time t. And TV2 represents the reserve at time t, given that Johnny is alive at time t and that Frankie has died before time t. We're also given that time 10v0, so the reserve at time 10, given that both Frankie and Johnny are alive at time 10, is 109,650. And we're asked to calculate the derivative of the reserve as a function of t for the situation where both Frankie and Johnny are alive, so for upper 0, at time t equal to 10. So we write out the Thiel's differential equation for this situation. The derivative of that reserve for the situation when both are alive with respect to time t is delta times that reserve. That's reserve growing with interest, and the force of interest is delta, and this is continuous reserve. And we are considering a continuous time differential equation, minus 10,000 because that's the rate of payout for the annuity while they're both alive, minus mu 65 plus t, and then it's the reserve for the situation 1 minus the reserve for situation 0, and that refers to basically a force at age 65 plus t, moving because the force of mortality takes out the one who's 65 plus t. Person of that age takes that person out, the person dies instantaneously, and then the reserve is transitioned from the reserve with the superscript 0 to the reserve with superscript 1, minus mu 55 plus t, and the reserve is transitioned from the reserve for superscript 0 to reserve for superscript 2. For t equal to 10, we are given that 10v1 is 8,000 times a bar 65. Frankie will be 65 then, and Johnny will be 75 then. So that's, and 8,000 is the rate of payment. So that is 103,133, and 10v2, 8,000 times a bar 75 is 77,810. So we just plug in all the numbers because we have them all. So the derivative with respect to t of tv0 at time t equal to 10, because that's the situation we're considering here, is equal to 0.05 times 109,650 minus 10,000 minus 0.017552 times the difference 103,133 minus 109,650 minus 0.005605 times 77,810 minus 109,650, and that's approximately negative 4,224.65, and that's answer A. And I actually added that we evaluating that derivative at t equal to 10. I should have put that notation there to make it clear. So that's answer A. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.